Hello, everyone. Welcome to Fine Home Building's virtual booth at the 2021 International Builder Show. I'm Brian Pontalillo, the editorial director at Fine Home Building and Green Building Advisor, and the moderator of this roundtable discussion. And we'll be talking about WRBs, drainable WRBs, and Rainscreens. And of course, for those who may not know, WRB stands for water resistant barrier. This roundtable is sponsored by Benjamin Opdyke, and we want to thank them for helping to make this event happen. So please check out their virtual booth at the Builder Show. And if you're not watching this video at the Builder Show, check them out online at benjaminopdyke.com. They offer high quality solutions for many of the things that we're going to talk about here today. And they have a whole bunch of knowledgeable people on the staff that can help answer your questions about their products. On our panel tonight, we have three top-notch professionals from pretty distinct backgrounds. I'm excited to have each of them here. So by way of an introduction, I'll start with Justin Fink. Justin is a licensed general contractor who focuses on the repair, renovation, restoration, and performance of historic homes in Connecticut. Justin will do a lot of things. So if you have work that needs to be done in Connecticut, check him out at finkandson.com. Is that right, Justin? finkandson.com?
Right.
Yeah, Justin was also a longtime staffer at Fine Home Building. He's our current builder at large, and he's the author of an article called Are Drainable House Wraps Enough? That takes a pretty deep dive into a lot of what we're going to talk about here tonight. So if we don't hit things, if you want some more information, you can look for that article on finehomebuilding.com, and you'll probably find out a lot more. So hi, Justin. Thanks for joining us.
Thanks. Nice to be here.
Yeah. Koda Ueno is a senior associate at the prestigious Building Science Corporation, where he does forensic field investigations of building failures. He consults on enclosure design and mechanical systems for new buildings and remodels, and he does computer modeling and verification of building performance. Koda speaks at all the important conferences, including the Fine Home Building Summit, and he writes for all of the important publications, including Fine Home Building and Green Building Advisor. And I had the luxury of editing a series of articles that Koda wrote for us in 2020. The series was called How to Look at a House Like a Building Scientist. And it was fun to work with him on that project. And if you have to do any sort of probing and sleuthing of a home that has problems, I recommend, and have troubleshooting to do, I recommend you look at that series. Koda, welcome.
Thank you, Brian. Thanks for the kind words. And it was, it was great working on that article series with you too.
Yeah, it's one of my favorites, and I know that it's gotten a bunch of praise in the industry. So I feel really good that we tackled that. And Kaylin Handy is the Technical Innovation Manager for Benjamin Opdyke. Kaylin has a diverse background in the residential construction industry, which he's been in for over 15 years. He's worked as a carpenter, a construction project manager, and he has a bachelor's degree from Temple University in business administration and real estate. He combines the practical hands-on knowledge with a passion for building science. And in his current role, he provides training for builders, architects, installers, and distributors all around the country, and cranks out as many as 50 training sessions per year in this position, trying to raise the level of education in the industry. So welcome, Kaylin.
Thank you very much, Brian. Happy to be here. I look forward to this discussion.
Yeah, me too. And Kaylin and I actually just met this morning. We had a call about some of the things that you'll be seeing from Benjamin Opdyke at the show today. And so 2 times in one day, Kaylin. We're on the roll.
It's going well.
So by way of an introduction, let me walk the title of this section backwards a little bit. So, and that's to say that not all homes necessarily need or will have a full vented rain screen. Not all homes will have or maybe need a drainable WRB, but all homes should have, and according to the International Residential Code, must have a water resistive barrier. For beginners who are listening, who may not know too much about this topic, may not know what a WRB is exactly. This is the water resistive layer that sits typically on the outside of the sheathing of a wood framed building. And if that still doesn't help, you just have to think about DuPont's Tyvek home wrap, because it's sort of the ubiquitous WRB. But clearly, in what you'll learn, if you are new to this topic, what you're going to learn here tonight is that it's far from the only choice. It's far from the only choice. So as common as it is, this is a field, this is a product category that's really worth getting to know. So the WRB is a really significant part of a home's water control layer, and the water control layer is the most important control layer. As you'll hear in this session, likely, a WRB can sometimes also play a role in other control layers. Most significantly, the air control layer, and new products are helping us get towards that. And it has at least an impact on the vapor control strategy in a wall assembly. So even if it's not used as a vapor control layer, it's going to have an impact on the vapor profile of a wall. And hopefully we'll talk a little bit about that as well. Hey guys, how am I doing so far?
Pretty good. Do we need to do anything here, or is it?
Yeah, you're doing the heavy lift, man.
I know I got a good critics here, so I just want to make sure I didn't blow anything so far. So I have not yet seen the 2021 International Residential Code because its publication has been delayed. But as far as the most recent code, the 2018 code book, calls for basically old school felt, or what the code labels an approved product for the WRB on a home. And Glenn Mathewson, a code expert, has told me that the best way to think about approved, first and foremost, is does your inspector approve of it? But also because that's what it comes down to when you're choosing a product or choosing a strategy, right? Is your inspector going to let it slide? But the International Code Council also has an evaluation service, ICCES, and they do approve products for acceptance in the IRC. So you can go to, and most of the things you're going to find commercially will be approved products, but you can always go to icces.org and search for products to get the approval document and to really dig into the product a little bit and see what the Code Council says is a proper use for that product. As I mentioned, as I alluded to, mechanically fastened house wraps, those that are installed, rolled out, installed shingle style on a house, and hopefully fastened with cap fasteners are the most common in the industry. I think a lot of that has to do with the fact that builders feel comfortable with them and understand the flashing details. But let's start right there. So let me throw this one out. Let me throw this one to you, Justin. The first question: why do you think? What are some of the reasons that common mechanically fastened house wraps have such a large share of the industry?
Oh, I mean, they're not very expensive. They come on a very large roll and they're very lightweight products, which allows you to, especially for new construction, cover a large swath of wall in one go without any horizontal seams, unless you're talking about seams between floors. And it's just sort of intuitive. It's like wrapping paper, like it's easy to understand the lapping of the layers, shingle style. So anything above is lapped over the stuff below. And it goes up fast with a hammer tacker. I mean, it's sort of, it's also it's very clearly from a production and durability standpoint, it's a big improvement over felt paper, which is what it replaced. Be careful to say that it's not necessarily performance is not necessarily an improvement over felt paper, which is an excellent product and arguably still one of the best out there. But like I said, it comes in a much bigger roll. It doesn't tear off the building when it winds. And it can stay exposed to the sunlight for a lot longer than felt can be without, kind of drying up and shriveling off the building. So when it came on the market, it made a lot of sense as the next iteration of felt. But as I'm sure we'll talk about tonight, it has some drawbacks also. Yeah.
So that's great explanation, and they have been around for a while. They are very affordable, and I think you could often wrap a single-story home in one pass, right?
Right.
So that workflow is certainly easy. Kaylin, you hear from a lot of builders in your role, and you guys sell some mechanically fastened house wraps. So what are some of the common misunderstandings with mechanically fastened WRBs, and what are some of the common mistakes that could cause builders problems?
Sure. And that's one of the great things just about, so a lot of my past was in historical Philadelphia. So it was kind of a great way to really see the evolution of the building products. because as we talk about these polymeric or these plastic house wraps that are now 9 or 10 feet, this was an evolution from that felt. And even before that, we never even had a WRB or a water control layer in our assembly. It just used to leak. And that was okay because we had durable products and we had no insulation or little insulation, and it could dry through. So I think one of the main concerns that I see is really the details. Is that now as we're creating these tighter and tighter building envelopes and we're using these mechanically fastened wraps, is that there is a lot less drying potential that moves through our walls as we're, creating these great air barriers. So from one stance, it's great from energy efficiency. But when we're looking at these wraps and how they're integrated with the windows and doors, I think that is really the biggest weak spot, is that we are now going from a mechanically attached and fashioned wrap, and then now we're using self-adhered membranes to integrate our windows and doors. And if they're not done correctly and we get water that's flowing behind these mechanical fastened wraps, it's the trapped moisture that really ends up causing large failures. Because, we look at the evolution of even our sheathing products. Is a long time ago, we didn't have sheathing at all. Is that we were using either board sheathing or none at all. We had the planks right against the framing material. So now as we're evolving and now we're looking at the sustainability of our industry. And so now we have to get more creative, and we're doing engineered wood products like OSB sheathing, which is extremely strong. But once we get water in contact with it, it begins to lose and break down its structural integrity. So that's where it's the details that really make a big difference on the success and the longevity of the projects.
So you mentioned something that about water being trapped if it gets behind the WRB, and you, I believe, and you correct me if I'm wrong, obviously, but at Benjamin Updike, you do something different than a lot of companies with mechanically fastened WRBs. You don't recommend taping seams. Is that correct?
Yes, that is correct. Because, and as you mentioned early on, the main primary principle of this WRB is water control. And not only do we want to have it shingle lapped, as Justin mentioned, and I always like to use the analogy from a shingle lapping standpoint, is that I don't tuck my raincoat into my trousers. So we always want to make sure that we're working our way up and getting that water down and out, because we've seen projects where they're taping the seams and then they're taping the termination at the foundation line. And now what you're doing is you're just creating a seal. And if there were leaks, or if we had a hydrostatic pressure build up and get into those fastener points, like your staples from your cap fastener or your siding nails, now you're creating a potential for trapped moisture. And that's where things go wrong. So if we're able to leave that open and look at our air control layer at a different position in the wall assembly, then we're able to have a more sustainable building if it were to get wet.
Yes, that it's been a while since I looked at the directions for house wrap, for something like Tyvek ubiquitous house wrap. But is it pretty safe to say you guys agree that the kind of the evolution of let's tape all the seams in house wrap was really an attempt to try and get it to be an air barrier, which inadvertently can lead to a lot of other problems. It's kind of like the last attempt to be relevant in the air barrier market, it seemed like to me.
Yeah, DuPont for a while tried to market Tyvek as an air barrier, and that's part of why they were talking about taping seams and various details like that. They had it can't. I think they've kind of backed off that concept and started to call it some kind of half-ass name. Half-butted term along those lines. But I completely agree with that potential issue of taping the bottom of the seam. I've seen exactly that at a window head. Hey, what's going on with the house wrap? Hey, we got a little water pillow going on up here that you can slit and drain the water out of, because they tape the water, the bottom edge of the house wrap at the window head.
Yep.
Yeah. And so, Coda, you're in your work looking at buildings, are the failures generally poor installations?
Yeah, and I've very, very seldom seen straight up material failures where if the product was installed well, it would have done fine. Installation problems, lapping, whether adhesives work correctly or not, the whole gamut of problems. But, honestly, a lot of the times with the materials, you look at the spec sheet, it does what it says on the box.
Right. And so I also saw you nodding a couple of times when Kaylin was talking about was saying that these are water control layers. And I wonder if you could step us back just a little bit and tell us the importance of the water control layer and why we look at it as the first control layer.
Yeah, well, the way that I always try to describe the water control layer, the water resistive barrier, whichever term you're using, is it's kind of the last line of water defense. So you have to think of the outside of your building, let's say a wall, has all these different layers that are stopping water along the way. Like ideally you have, some roof overhang, so at least the straight down rain is not dumping directly on your wall, unless you're doing a fancy modern house that has zero overhangs. Then from there, you have the cladding, the clapboard, the brick, the stucco, whatever that outside material is. And you can consider that the water shedding layer. Basically, water gets blown by the wind, hits your wall, but hopefully mostly stops at that outside layer, the clapboard or the brick, and then, has drip layers, etc., that generally direct it away and out, flashings, etc. However, you can definitely assume that some of the water will get behind that cladding to the water resistive barrier. So you want a water resistive barrier to ideally be, if you sprayed water on the building without any cladding there, you'd still have shingle lapping, you'd still be basically watertight and water would run downhill and out. But, in terms of the control layers, you're completely correct that the water control layer is the most important one for durability, callbacks, etc. One of Joe Stebrick, my boss, his classic lines is, builders get callbacks all the time for leaks. They don't get callbacks for, hey, my building's leaking air very often.
Yeah, this is uncomfortable. Help me.
Yeah. So we've been sort of on this we've been talking about mechanically fastened WRBs and while they do have the lion's share of the market right now, they also have a lot of competition, and more. It seems like more and more each day. And there's now self-adhering products that are similar in the way that they're installed and lapped, but they actually adhere to the wall with adhesive. We have integrated panel products, Zip, and their similar products, and we have fluid applied products. So I guess I'll throw this question out to all of you. What do you think's what are the most interesting kind of developments with these sort of basic WRBs?
I think the fluid applied is really interesting for new construction. I mean, we've been seeing it for years and years in commercial before it even started to, creep over into residential, which is a sort of a common trajectory. It was successful in commercial, so we'll find a way to screw it up with residential and ruin its reputation. For my world, being old houses where air leakage is a huge concern, the self-adhered they solve a lot of problems. Because they're just, they can bridge gaps between old board sheathing, unlike other, they really can handle a couple of things in one go. Whereas an integrated sheathing product, maybe I don't have room to add 7/16" sheathing on top of what I've already got. I just need a thin layer that's going to do the job and provide the air sealing as well as the water control. The drawback there for me, that between those two, fluid applied and self-adhered, is they're not very reversible. And in my world, and even outside of the historic world, I keep on putting myself in the shoes of the next generation, and I keep on jokingly thinking, well, it'll be my turn to retire as soon as I get called to a house where I have to rip, peel and stick off of a wall, because forget it. I'm just gonna here's my keys, I'm done. So that's kind of concerning to me, that we're starting to develop more and more tenacious products that, maybe are going to make remodeling harder. we could go all day to talk about just the fact that we don't have kind of a standard assembly anymore these days. Where it used to be, stud walls with fiberglass and then house wrap on the outside. Now, you ask 10 progressive builders what they're doing, you get 10 different answers with 10 different series of products. It's kind of the Wild West right now. So I guess I'm being conservative. I'm nervous about where all this is going. I love the performance aspects of it, but the new products make me nervous too, in the sense that we're changing a lot of things quickly and it's getting complicated.
Sure. And if you decide to build with, let's say you decide to build with a different wall assembly because it has some benefits right now, and that wall assembly doesn't take off, you've got a house that a builder in 50 years is going to try to work on it and say, what do I do with this?
Right. Or just simply want to add an addition onto, and now that whole wall is toast because I can't get one layer off of it.
Yeah.
Yeah, and that's a great point. And Justin, as you mentioned, the Wild West and how products usually kind of convert from the commercial space. And it's so true, is that we are dramatically changing the details of our assemblies. We're making it so much more complicated than ever before in the history of the building industry. And now we unfortunately have such a lack of skilled labor, or a labor force that wants to learn the skills or the details that go into it. Whereas you look at what was done 100 some years ago, when we actually had carpenters that, could do a mortise and tenon joint by hand, and, they took the pride in it. So it's such a dichotomy or difference between the last 100 years. And it's kind of scary as to what that next phase of the construction is. And right now I'm renovating my kitchen. And when we talk about kind of reversing things, I just took up 1.5 inches of 4 different floors in my kitchen. And it's just kind of funny to see what was done in the 70s, where they're physically using asphalt adhesive to put the tiles down, and then putting Lawan over top of that, and then linoleum, and the progression of these products. And I almost think it's going to be kind of the same thing in the next 50 years is, okay, we tried this mechanical fastened wrap, and that seemed to work for a period of time. And then we went and we stuck something to it, or then we sprayed some fluid on it. So then the next generation is going to be ripping off the cladding and be like, oh man, I got to go through all this in order to get down to the sheathing layer. But I don't know if there's...
It feels sort of like commercial roofers figured it out when they started integrating a slip sheet underneath their adhered roofing. Like sounds like they got tired of ripping off hot tar roofs. Maybe we should put something down so that when we put our new roof layer on, it has something that will separate it from the structure, make our lives a little easier later.
Yeah.
But are you sharing the concerns that Justin and Kaylin are bringing up?
That is a fair point. Demolition will be awful for sure, but on the flip side, we've been using self-adhered membrane, grease, ice, and water shield over roofs for a while, and roofers have pretty much gotten to the point of like, yep, we have, an ice and water shield layer, we just put on another one down on top of it, and that's the answer, because we sure aren't ripping that stuff up.
Right.
It's not coming out without taking the sheathing off.
Yeah.
So
Brian, to get back to your original point,
Yeah.
I think was like just talking about what's exciting in fluid apply self-adhered. So, this is something that everybody here knows, but just to spell it out kind of a little bit more systematically, what I see as the advantages of a self-adhered membrane on a wall are, number one, it makes a fantastic air barrier. I do not trust, a mechanically fastened house wrap as a air barrier layer. It can be done, but very, very seldom it is done successfully. Self-adhered membrane, you connect all the seams, bang, you have a beautiful air barrier. Second thing is that it eliminates that hidden path behind the wrap. The classic thing is where you have a tear in the house wrap, water gets in behind, and it goes from point A on your wall to point J, and you don't know where it came in compared to where it's coming out. A properly self-adhered membrane, basically, yeah, you'll have a spot where your sheathing rots out, where you have a problem, but it's not going to get everywhere.
Oh, that's interesting. I guess I hadn't thought of it that way yet. You could have a gap behind your self-adhered membrane, but if the rest of it is adhered well, the water's not going anywhere. So you're going to have an pretty isolated problem.
Yeah.
And the self-adhered membranes are also improving as a category, right, Coda? I mean, now we have some whereas they used to be a barrier to vapor, now there's some ability to dry, which
Yeah,
is
absolutely.
which is
Yeah.
nice.
Yeah, absolutely. So the old school adhered membranes, when we're talking about the commercial world, are things that are vapor impermeable. Basically the same concept as taking ice and water shield and putting it on a wall. The generation that's been out since then is a self-adhered membrane that is vapor permeable, allows drying. I consider it like a 1-for-1 swap with a house wrap, but with better properties.
Yep.
So, and we're going to ask Kalen about a very specific product, but we're going to wait till we get to the next category of the discussion, where it fits better, and he'll be able to expand a little bit in a specific way on what you were just saying, Coda. So, but before we jump up to that next category, I want to just sort of ask you, now that we've surfaced a bunch of different types of WRBs, sort of in general. I know we're not going to be able to answer, like, be too specific on this because you need specificity to do it. But in general, you have a wall assembly and you're looking for a WRB. What do you need to know to choose? What are the how are you sure, when you're looking at your wall assembly and looking at potential WRBs, that they're a good match for each other?
I would just ask Coda.
Yeah, I'm not quite sure how to answer that question. A lot of the time, you start with a house wrap as a baseline. If you're talking about higher performance, you're moving up to the self-adhered vapor permeables or the liquid applied. A lot of this depends on what's your wall layup. Are you doing continuous exterior insulation? What's the rest of the wall? So a lot of questions to figure out from there.
Yeah, and I guess you keep mentioning the vapor permeability, so I guess that's one thing, that in most cases you're looking for a vapor permeable product on the exterior of your wall.
Typically, cold climate chauvinism here. I'm in Massachusetts, so.
Yeah.
But yeah, and that's always the first question that I ask is, what climate are you building in? And then, what type of insulation are you putting in the cavity? And do you have the exterior insulation? And when we're looking at really the basic need for a WRB, one of the things that I do like to delineate is between a woven or a non-woven house wrap. And really the main reason for that is the technology in which they have to put or create a permeance or a perm rating. So there has to be some sort of vapor passage through these WRBs. And for a lot of the woven type products, and that looks kind of more like a lumber tarp that's actually interwoven together, is that they actually have to perforate it. And it's called micro perforation, where they actually poke little tiny holes into this wrap. And that is to achieve that permeance. However, those little tiny holes also ruin its water holdout. So basically, if liquid water were near those holes with pressure, it can force it through that product. So typically, that's one of my bare minimums, is that just let's look for a non-woven type of a wrap that has a microporous layer to it, whether it be a film or the technology in which the material is created. And that's really just a great starting point. And then from there, we're going into the type of cladding that you're using. If you're looking at a Rainscreen, is always a great idea, but that's just a great starting point for your WRB selection.
That just to back up what you just said about the perforated products, the only independent study of WRBs that I'm aware of, and I think it's from the 90s, it was done at UMass. And I believe that was one of their findings. And I believe that was in what I've read about that study. And Justin, you may remember more of this than I do, but what I read about that study is that was the one sort of significant finding, is that failures were common in the perforated products.
Yeah, that was Paul Facette did that study.
Yeah.
That, and he walked away saying, I would still use felt paper if I was building a house today.
Yes.
Which is kind of an interesting revelation, interesting counterpoint. So much of that study is still relevant today.
And I think that you can find that through a Google search. So Paul at UMass Probably house wraps at that time. I bet you would be a good search term to look under.
Yep.
Okay, so let's sort of step it up a notch and talk about sort of the next step in house wrap, which are the drainable products. So since you wrote that epic article, Justin, why don't you tell us what a drainable house wrap is?
So a drainable house wrap is essentially it's an altered house wrap. It's altered in some way to create a little bit of a gap between itself and the cladding that you're going to put over it, and that can be accomplished by kind of crinkling the house wrap, dressing with like little dots of some kind, adhesive, or like little dabs. Sometimes it actually has a groove, kind of a texture to it, almost like the feel of a basketball, where it's kind of like multi-directional. Basically the idea is that even a little bit of space between the back of the cladding and the house wrap is going to drastically improve the flow of water behind the cladding. So when you see, and everyone who's watching this has probably seen at the lumber yard or at trade shows, the little manufacturers set up for the different drainable house wraps that shows a massive amount of water pouring behind a piece of plexiglass. And look how much water flows behind this. Yeah. Oh, there we go. Yep. Not picking on you. We're about to pour it through. Here we go.
So yeah, sorry, you can keep talking. I'll just be your Vanna White.
We got the blue liquid. This is, as Brian mentioned, this is sort of the next step up from a flat house wrap because it offers a little bit of an increased drainage potential.
Yeah, and you mentioned that the gap doesn't need to be very big. And Coda, one of your mentors, John Straub, I believe, did some of the early research on this. Oh, there it is, Kaylin. Nice.
There you go.
And I believe that he said that the gap can be as little as 1/32 of an inch, and that's enough to drain water as quickly as a common storm would be putting the water could be getting water behind the siding. So is that Coda, is that consistent with your understanding of?
Yeah, anything John Straub says you can pretty much take to the bank. We sometimes throw around 1/16 of an inch. A lot of the time we get the question of like, how big does this gap need to be for drainage? And so the whole concept is if you have two flat materials that are smashed flat together, you have a perfect way to get water hanging up there by surface tension, just by wicking. Or it kind of funnels in and cannot drain out. So my answer to how much of a gap do you need is like, how tight do two staves of a barrel have to be watertight? Less than that is the answer.
Hey, good answer. So let me follow up with you on that, because I've heard, and I've only heard this anecdotally, that some products, integrated panel WRBs and maybe some rigid foams that qualify as WRBs actually have irregular enough surfaces to allow for drainage. Is that something that is correct, and is that something that a builder can rely on?
I believe that I've seen data from Huber on their Zip product, because that has definitely a crinkled surface, and if they told me that it has a drainage efficiency of blah %, I'd say yeah, probably. In comparison though, nailing up like a hardy board directly against a flat surface of plastic foam like polystyrene, I think that might gasket pretty hard, especially as the foam squishes a bit.
Yeah. So Kaylin, you at Benjamin Opdyke have one of the most well-known drainable house wraps, and from what I've heard, again anecdotally from builders, one of the most trusted. So can you tell us a little bit about HydroGap, what it is, how it works?
Yeah, and with HydroGap, we actually we do most of our development and research comes from our builders, and we've worked with the Building Science Corporation and a lot of the research that they've done. And when they were talking about a 1/16 of an inch space or a 32nd, is that we wanted to make sure that we could incorporate something of that nature. And so with our spacers, we're creating about a 1 millimeter gap, so about a little less than a 1/16 of an inch. And we're really trying to just break that hydrostatic pressure that can build up. And by having that small space, and it's not large enough that it's going to change your window details or have to pack out the window profile or the trim, but large enough just to get that moving in the right direction. So using gravity to get it down and out. And that's where it's really actually exciting to see siding manufacturers that are now going with that same sentiment. Whereas LP SmartSide with their flat to wall panels are now mandating a 1 millimeter non-compressible space. And it's more than just a drainage efficiency. Because one thing when we're looking at the ASTM tests and the methods that they're using, that for a drainage efficiency that was designed for an EIFS type system, like an exterior finish insulation system, but we want to look at how quickly we can get that moisture out. Because a lot of these tests, like the EIFS, it takes about 2 to 2.5 hours is the window of time that they set up this assembly, which would be similar to this. They put a measured amount up top, and then they calculate how much they have at the bottom, and that's your drainage efficiency, right? So if you have 10 ounces in here, you got 9 ounces down here, 90%. However, we want to make sure that we can get that out as quick as possible. And that's where we're seeing with the HydroGap technology has really been successful because of how quickly it can escape the assembly, even with a mechanically fastened. Because I know I love one of Joe's articles, Joe Stiebrick, was you're going to have thousands of holes penetrating your WRB or your water control layer, and especially if it's mechanically fastened. But those aren't going to leak unless there's a significant amount of pressure that builds up at that penetration point to drive it inward. So if we can get that forced down and out, then we're in good shape.
That reminds me of, I've heard, I'm not going to mention his name in case I misquote him, but a pretty well-known building scientist who has told me many times that the unfortunate thing about testing for WRBs is that no one's testing or that no one has to test for water stuck behind the siding, just stuck there, not going anywhere. And he predicts that they'll all fail if the water just stays there forever, if it's just stuck against the WRB forever. So before I ask Kaylin you about the new product, can you tell me why the spacers have that pattern?
Sure. And
the wavy pattern.
Yeah, so with the wavy pattern, what we were looking at is, number one, it can be installed any direction. So regardless if you're rolling it straight down or if you're rolling it horizontal, you're going to get that that drainage. And another reason is that as we have, like, let's say a butt joint. And so if we have products, it's going to be sitting on several different rows, several different spacers, and it's not going to be kind of falling in the crevice if this were just a straight up and down pattern where it could potentially fall in the middle. So just something that we were trying to play with to make it. And again, that came from Builder Insight. It's like, hey, have you guys thought, because if you have a straight pattern and you have a butt seam that falls right in the middle of those spacers, you're going to get a seam that's not exactly flush. So that's a great question.
Okay, so thank you. Now tell us about the new HydroGap.
So now we took HydroGap. So we took our mechanically fastened HydroGap and we coated it with a continuous acrylic breathable adhesive. So what is great about this, as our industry changes, we seem to be kind of one of the last industries to get the technology advancements, but acrylic adhesives have been in the automobile industry and in a lot of others for a very long time. And the acrylic is known for its performance characteristics from longevity, UV stability, and stability in thermal movement and as the temperature changes. So we've been able to do a full continuous coating. And what that means is that there's a lot of products on the market that have a discontinuous adhesive coating. So basically, if you would picture like a silly string, and if you were to coat the backside, the whole point of that technology is to leave spaces or voids in that adhesive because they need to still have that permeance. And majority of adhesives on the market are vapor closed, so they don't breathe. So with this acrylic technology, we're able to have that fully continuous coating. And then with that adhesive, and I don't know if you'll be able to see it, there's actually like a kind of a reinforcement scrim that is applied with that coating. So this gives it an extreme amount of tensile strength or tear resistance, and particularly in comparison with our HydroGap product. So now with this, we can fully adhere this to our sheathing. And now we're taking it up a notch. So we're number one priority is that water control, which we're getting naturally with HydroGap. But now with that fully self-adhered, we're now sealing around all of those siding penetrations. So we're creating a better air barrier. And now, because regardless of your air control layer, there's always going to be interior air sealing that has to occur, because we have to look at the structure. It's not just walls. That wall has to connect to that foundation, to that foundation layer, and then up to the roof. So we got to have a 6-sided box. So this is just one step in that air barrier strategy.
Yeah, and for those who may be listening who don't know this, because it hasn't, if you are very likely a builder who this hasn't come to your area yet, but the International Residential Code also now has requirements for air sealing. And so that is something that's going to be coming to more and more builders to have to verify that their houses meet those requirements.
Right.
And so these products are going to be one of your options for getting there. So, Caitlin, what is the permeability? What's the perm rating of the new product?
So this perm rating is 12 perm. So all of our products, we do like to stay in that 10 to 20 range, which is another great range supported by our friends at the Building Science Corp. And a lot of the research that we've seen is that, and a lot of the failures that we've seen in the Mid-Atlantic area with inward solar drive around the stucco apocalypse, or the failures that we've seen in the early 2000s with a 3-coat stucco applied to a single or double layer of high permed house wrap, is that liquid water that is absorbed by that stucco can turn into vapor, just like my wife's diffuser here. And it can actually get pushed through this high perm rating into the sheathing. So we do like to have that lower perm to really control the exterior moisture and limit it from getting into the building assembly.
So I know that all adhesives really, but in our world here, the adhesive, the acrylic adhesive common to building tapes and your self-adhered wrap, they're pressure sensitive, right? So what's with those bumps on the material, does that affect the way that I would roll it out after application to make sure it's adhered fully?
That's a great point. And because that's not even just with self-adhered wrap, but just with flashing tapes in general, because that's one of the biggest failures that I see, is that you're not putting pressure on that surface. And you made a great point with the texture. So a couple of different products that I've used to really get good pressure. Number one, I would recommend a dense, coarse push broom. So something that's on every single job site that has a large head to it, that you can actually get a firm pressure onto that surface, or also a driveway squeegee. Just like if you were going to, top coat your driveway. So that type of a rubber actually conforms around the spacer so you can get good pressure. Because that is critical to not only the surface prep, making sure that your sheathing or your substrate is as clean and dry as possible on a job site, but also getting that pressure into all the little nooks and crannies is important.
And you said it can go horizontally or vertically?
Yes. Yep. So you can roll it straight down. So I have some larger projects where they actually have a lull or a machine where it's easy for them to just take the roll up to the top, and then they can drop it straight down, kind of realign it. And that's one of the nice things with the acrylic adhesive, is that it is repositionable. So if you put it on the sheathing, you got some wrinkles, you don't like the way it lines up, you can pull it straight off, readjust it, and the adhesive's good to go, as it takes a little bit longer for acrylics to cure versus, say, a butyl type of an adhesive.
I've heard some builders who have worked now with self-adhered products say that the vertical installation really makes them easy to work with.
Yeah.
And I just, we don't have time to get into all of the installation details of a self-adhered product in this session, but I do want to just stress that point that these products have to be rolled. You haven't activated the adhesive if you haven't rolled them, and that goes for most of the peel and stick things we're using on a home these days, if not all. So if when in doubt, roll it out. Just make sure you're doing that.
That trademarked?
I was gonna say.
Well, I need a product to go with it, so watch out, Benjamin Obdyke. Okay, so let's jump up to the next category of our discussion, which is ventilated rain screens. So Justin, a WRB is just one part of a ventilated rain screen. Can you describe what a rain screen is, what it is, and what a site-built rain screen kind of looks like?
Yeah, sure. And I take kind of a hard definition of this. Like I know I'm a little extreme with this, and some people don't agree with how extreme I am on it. But the rain screen term is used loosely, and the rain screen portion of a ventilated rain screen assembly is really the outermost layer. So in a typical case, it's your siding. That's what's blocking the rain. Then there's a gap behind it, which is a component of this rain screen assembly. And to further my kind of militant view of the terminology, it's a former editor in me, I can't help it. I like to think of it as, and this was in that article that Brian mentioned, Are Drainable House Wraps Enough? A vented rain screen, in my eyes, is one that has a vent at the bottom, but not at the top. Which would mean that any water that gets in can drain out the bottom, and air can still flow in to a certain extent. Ventilated rain screen assembly would have an intake at the bottom of the wall and a vent at the top of the wall, so that you can have air all the way flowing all the way through. The idea behind any of these being that you are increasing your drying potential behind your siding. You're just like the drainable house wraps, you're trying to get water out as fast as possible, but with a true vented or ventilated rain screen assembly, you're adding air into the mix, which you're not getting with a drainable house wrap. And I think that's the big difference that not everyone understands. And even Kalen, during his description, had a little bit of a slip of the tongue, where he said you're letting air in. It's like, it's so easy to lump it together and think that you're doing the same thing. And it's not necessarily the same level of protection.
Justin, would you like a job at the nation's top home building magazine?
Brian?
What do you think of what Justin just said? A ventilated rain screen is more than a drainage space. What are the benefits of going to that level?
Well, first of all, Justin, I have to thank you for using the correct terminology, vented versus ventilated. John Straub's mentor and advisor is Dr. Eric Burnett, who's, he lays his blessings down on you from Canada for using the terminology. He's the real stickler on this front. So the benefit that we're getting here is that air that's flowing behind provides drying. So we're looping through outside air. So we're taking, basically that's the way to evaporate the liquid water that's held up in that ventilated rain screen space. Even though it might be high humidity out, in general, in the balance of things, having outside airflow go through that gap is going to dry out your wall wherever you are. And we have boatloads of studies showing this, even in like the damp Pacific Northwest. Adding that ventilation does dry out your walls. The other chunk of that is, what's also a benefit is having a more noticeable gap, not the tiny 1/16 that'll let water drain down, but by pushing that out to, say quarter, 3/8, 3/4 inch, what have you, that's more of a gap that any dot of rain has to jump across to get to your vulnerable backup wall.
Yeah. And so when we're talking about drying, we're talking about, there it is.
Capillary break.
Yep.
Watch those dots of rain jumping. You got to watch out for that.
We're talking about, so far, I think the way it's been used, like any water that is in this space drying, you know, it has the airflow to promote drying, but it allows better drying of siding and assemblies that might be wet. Is that correct?
Absolutely. Both, it dries out both your outside cladding, whether it's brick, clapboard, etc., and it dries out your backup wall.
Yeah.
Yeah, just to give an example of, the claddings all leak. That's one thing that Joe repeats over and over. Early on in my career, he had a very edifying experience where we went to a building, busted open the wall from the inside, and then started spraying the outside brick layer with a hose. And less than 5 minutes later, you're starting to see on the backside of that brick where we've busted into that cavity, drip, 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 drip. So water does come through.
Yeah, Joe really got that into our head at Fine Home Building. Maybe, I don't know, Justin, you probably remember this. It was about 20 years ago, and we started hearing that like a mantra. And at first we would have like sort of a question mark at the end of it. Siding leaks, and then after a while we started siding leaks. Yeah, we started. It was like siding leaks. You guys, you need to know this.
Well, it's amazing because it's like people are still holding on to that. Like, well, come on. I mean, you've got cedar sidewall shingles and 3 layers. That's not leaking. Yeah, it's gonna leak. Everything leaks.
Yeah.
Get over it.
So oftentimes the Rainscreen details are built on site using like furring strips, for example, fastened to the framing through the sheeting to the framing, and then siding can be attached to the furring strips. And then, there's of course other details like, insect screening at the bottom and different flashing details that you need. But there are also products that can solve this building problem for you. So Kaylin, why don't you jump in and tell us a little bit about what you guys have to create a Rainscreen?
So really, just to reiterate, is that we're really trying to create that capillary break. Is that we want to prevent water from jumping across, and we want it to drain through. And when we're looking at as we talked about, the mechanically fastened flat house wrap to the drainable to the Rainscreen, it's kind of, we're looking at a good, better, best type of an assembly. And one of the misconceptions out there is that a drainable house wrap is a replacement for a Rainscreen. It's false. Is that we need to have enough space to allow for that air to circulate and really get that maximum drying potential. And one of the products that we have to create that would be our slicker line. So we're using a entangled matrix that allows for about 1/4 inch space behind your cladding and allowing for it to get that air to flow. And as that air flows, as they mentioned, is that we're going to carry with it moisture. And that is from the cladding and also enhance the drying of the assembly wall cavity itself. And that's really the main go-to when we're looking at reservoir claddings. When we're looking at something like a brick or a wood or cedar type siding that actually absorbs a lot of water, we want to make sure that we have enough drying potential in that assembly to dry it out, and that's going to really increase the longevity of that paint or that sealant that is on the surface of that cladding. And that's really the biggest ticket, is that because obviously as we look from a standard house wrap to a Rainscreen, there is a cost difference that goes up as we're going through. But when we take a look at a Rainscreen, the benefits long-term versus the amount of maintenance that you have to do to your exterior cladding and the drying potential, it's really a no-brainer. As it's just trying to get those details in the field, because 1/4 inch makes a huge difference in your window details, whether it's an extension jam or you're packing your trim out. So those are the type of conversations that we like to have up front, just to make sure that our builders are thinking about those details beforehand.
Can you say, for anyone who doesn't know, can you say what a reservoir cladding is?
Yeah, reservoir cladding. So if you were to take that cladding and you put it in a bucket of water, is that cladding going to weigh more or less? So typically if a brick, you pull that brick out, it's soaking wet. Same thing, even with a fiber cement siding, over a period of time, that's going to absorb moisture. However, if you look at the other spectrum, a piece of vinyl siding or PVC trim, you put that in a bucket, it's inert. It's not going to absorb that moisture. So as we're asking questions about what's the best water control layer or system for you, that is one of the great qualifying questions, what type of cladding you're using, along with the climate and the insulation and understanding all the layers.
Yeah. And so when the sun comes out and starts to hit those reservoir claddings, there's only one direction for them to dry, and it's towards the house, right? So that therefore
Actually, it goes both ways. It is evaporating off the outside, but in general, the old term Joe used is moisture moves from more to less and from warm to cold. So you blast that brick to heat it up to 100 degrees. Yeah, some of it's going to be going inward. And if you have something that stops the moisture, like a polyvapor barrier or vinyl wallpaper on the inside, yeah, you can end up in a world of hurt.
So therefore the benefit of having that space where that it can dry into, and
it basically whisks that moisture away by that ventilation airflow.
Yep.
Yeah. So okay, so for closing thoughts, Kaylin mentioned a good, better, best scenario with WRB, Drainable WRB, and Rainscreen, and I'll be curious to if you all think is that a pretty hard and fast rule, or are there circumstances where money's no object? Are there circumstances still where drainable house wrap's enough, where you don't need a full vented rain screen, or where regular WRB is enough?
A lot of it depends on exposure. If I'm building in, Colorado where it barely rains, yeah, I'm probably not going to be going crazy on rain screen details. But if I'm building in, coastal South Carolina or in the Pacific Northwest, yeah, I'm probably going to get every bit of drawing I can get my hands on.
Yeah. And what about Justin? You agree with that?
Yeah, I mean, I think the good, better, best thing, nothing is absolute, I guess, in the world of building science, but I think the good, better, best is probably a good way to think about these products. And like Coda said, there's exceptions. I mean, you live in the high desert, 3/4 of an inch of drainage behind your siding might be kind of silly. But I'd say in general, the closest we can get to an in general statement, sure. Yeah. I think the better, best makes sense.
And I'll point out, and you guys correct me if I'm wrong on this one too, but there are some siding types that are self-ventilating.
Absolutely.
So vinyl siding, for example, right? You wouldn't need to put that on a rain screen.
Exactly. It has an airspace built in behind it, unless you're talking about those insulated vinyl products, which gives you minimal insulation and eliminates your benefit of ventilated rain screen.
Don't use those.
Yeah.
And I've also seen some, or at least been told that there are some metal siding products that also are well ventilated. So that would be another exception, I guess, to the good, better, best rule. Okay, well, hey, thanks again to Justin, Coda, and Kaylin. This has been a great discussion. Thanks to Benjamin Obdike for sponsoring this session. Check out their virtual booth here at the 2021 International Builders Show, or find them online at benjaminobdike.com. For lots more information on this topic, you can go to findhomebuilding.com, greenbuildingadvisor.com, and buildingscience.com. Coda, I did not mention that when we started that you guys have lots of great free information on your website.
Tons.
Yeah. It's where we start our research.
It's a great resource.
So check it out, everyone. Have a great time. Enjoy the rest of the show. Thank you.